Hello, Math 1430 classes. I just want to do a few more examples from section 6.1. Just some basic integrals, so that way you get familiar with these properties a little better. So I've got, it looks like 5 integral problems I have. 5 integral problems. So each one will take just a minute, no longer. Okay, so once again, my brother's going to take me. Here's my brother. Alrighty. Okay, so by property of integrals, you're allowed to pull a constant factor outside the integral. So this is the same thing by property of integrals, 5 times the integral of x cubed dx. You can only pull out constant factors. Do not pull out x's, only constant factors. And this is going to equal 5 times, and now here's the power rule. Whenever you see a power, you can use the power rule for integration. So what the power rule is you increase the power by 1 and then you divide by that number. Since I'm going to apply that power rule of integration, do not write these symbols anymore. They both disappear on the next step. So 5x to the 4th over the 4, and then don't forget that constant of integration, plus c. So that's my final answer. We are done with that first problem. Okay, the integral of e to the x dx is always just e to the x plus some c. And here's the proof. If I take the derivative, do I get back to the original? Hell yeah. So we're done with that problem. Now, here's the next one. The integral of x to the negative 1 dx. This is the same thing. These problems are identical because x to the negative 1 means 1 over x. But this problem is a little more tricky than it looks because I see a power, but we cannot use the power rule. This is the only power that you cannot use the power rule. Because if I were to use the power rule, I would get negative 1 plus 1 is 0. So could my answer really be x to the 0 over 0? No, you can never divide by 0. So just try to remember, whenever you have the integral of x to the negative 1, it's the same thing as this. It doesn't matter which one you choose. In either case, here is the answer. The natural log of x in absolute value plus c. And we're done. And we know that's right because what's the derivative of the natural log of x? We know it's 1 over x. So this is just something you try to remember because of all the rules, this is the one that most people forget. You cannot use the power rule. It's just the natural log of x plus c. Okay, for this problem, you never want radicals, so I'm going to rewrite it as the integral of 1 over x to the 1/2 dx. And here's something kind of important. We know with derivatives, we have quotient rules and we have product rules. But for integrals, we do not have quotient rules and product rules. So to avoid a quotient, I'm going to do this key step. Bring the x to the 1/2 on the bottom upstairs as x to the negative 1/2. So try to feel comfortable with those rules of exponents. And as a check, isn't x to the negative 1/2 the same thing as 1 over x to the 1/2? So this looks kosher. I did not integrate, I just simplified. So that's why I still have these symbols. Now I'm ready to integrate. I'm going to use the power rule because I can always use the power rule when the power is not negative 1. So for my answer, I'm ready to do the power rule. Add 1. What's negative 1/2 plus 1? 1/2. And then over 1/2, and then plus c. But this needs to be simplified. Dividing by a fraction is the same thing as multiplying by the reciprocal. So dividing by half means multiplying by 2. So 2x to the 1/2 plus c. You can leave that as your answer, or if you prefer, x to the 1/2 is the same thing as square root of x. So either one is good. This one's slightly preferred because the original problem had square roots. So I returned to square roots in my final answer. Okay, and then finally, the integral of a sum or difference is just going to be integrating term by term. So I'm ready to go. I'm going to write equals over here. Get rid of that. Okay, so just what's the integral of the first term? It's going to be, pull out that negative 3. And then the integral of x squared is x cubed over 3 plus. And again, whenever you have a constant times x, you can pull out that constant. And then what's the integral of x to the first? It's x squared over 2. Don't worry about the plus c until the very end. And then minus the integral of a constant is going to be that constant times x. Now you write plus c, and then finally you always want to simplify when you can. The 3's cancel, so I get negative x cubed plus, and then what's 3/4 times 1/2? 3/8. So I'm going to pull out the 3/8 x squared, or you could write 3x squared over 8 minus 2x plus c, and we are done. So that was just a quick video since I already did a 6.1 video. So take a look at that. Feel free to hit pause on your video to look at it. Okay, good night, everyone.